coming up from AMNH. And so we heard a little bit about bryozoans earlier, but now you get to see a lot more about bryozoans.
Okay, hello everyone. My name is Mireya Lopez Guzman, and I'm from the American Museum of Natural History. Today I'll be talking about the digitization workflow for wet bryozoan marine invertebrate collections. So here's an outline of what I will be talking about today. First, I'll talk a little bit about the marine invertebrate collections at AMNH. Then I'll go into an overview of the bryozoans, and then a digitization workflow for wet specimens, which has three main steps: cataloging, imaging, and databasing in EMU, our collections management software. And then I'll talk about our current digitized bryozoa collection and the progress that we have made since being a part of the NSF DigIn grant. And then lastly, the benefits of digitizing this collection. Okay, so the marine invertebrate collections at AMNH are extensive. We have 29 marine invertebrate phyla represented. They have been largely undigitized until now, so they haven't been easily accessible to other researchers and the public. But with the NSF DigIn grant, it has allowed us to digitize the non-mollusk marine invertebrate collections, such as the ones pictured on this slide. So I'll talk about the bryozoans next. So what are bryozoans? They are generally sessile, filter-feeding, colonial aquatic invertebrates. There are marine species and freshwater species, but they're mostly marine. It is a species-rich phylum with around 6,000 species distributed worldwide. Colonies are made up of zooids, which are individual microscopic members of the colony. They have feeding structures called lophophores, which is the kind of tentacles that the bryozoans use for feeding. So bryozoans have been an often overlooked phylum, perhaps because of the zooid's small size, and perhaps because the colonies can take many shapes and forms, so they can be hard to identify. They're a complex group to digitize as well. In our collection, we have dry, SEM, and wet bryozoan collections. They each require different workflows, so we have decided to focus on digitizing the wet collections first. So far from the specimens that we have cataloged and digitized, we have 469 species identified so far, but we do have around 1,700 specimens that have just been identified to the phylum Bryozoa level, and others that have just been identified to the order or family level. So within those specimens, we may have new species that would be new for our collection, or perhaps to science. Okay, so I will talk a little bit about the bryozoan specimens that we have in our collection. So here are some specimens. You can see the different forms that bryozoans can take. So on the left is an encrusting bryozoan on a rock, and the middle is a Celeronella species that has a branching structure. And then we have a bryozoa that has a fan-like sheet form structure. And here are two other examples of what bryozoans can look like. Okay, so how do we get these specimens and their data into our database? First, we need to catalog them. So we use a QR barcode to do so. We have a sticky barcode on the lid, as well as a non-sticky barcode inside the jar. The non-sticky barcode is made up of polytag, which is a white polyethylene tag stock. And we use a thermal transfer printer to print out the barcode. Okay, the next step is imaging. So I used a Canon EOS R5 camera to remotely shoot the specimen, so I could see on my computer monitor that everything was positioned correctly and in focus before I took the image. So I imaged the barcode, the color checker, the ruler, the AMNH logo, collection label, and specimen. So retrieving collection labels from jars and returning them to a jar can be time consuming. It can also take time to flatten the collection labels if they've been rolled up inside the jar or if they've been stuck under a specimen. Also retrieving specimens from jars and returning them to the jar can take time. For the bryozoans, we decided, since bryozoan colonies can be hard to identify without a microscope, that we would just shoot them inside the jar. So after we take the image, we use barcode filer, which is a computer program, to rename the images to the barcode number. And barcode filer uses the barcode in the image to do so. So it's a fast and efficient way to rename these images. Okay, so next is databasing in our collections management system, EMU. So it has 5 main steps: creating multimedia records, creating catalog records, attaching the multimedia record to the catalog record, transcribing the verbatim collecting text, and then filling out the other fields, such as locality, collector, states, habitat, etc. So I'll talk about each of those steps individually. So as mentioned before, we use EMU at AMNH. So far, I have liked using it. It has different modules, such as locality, taxonomy, multimedia, catalog, etc. But once you get used to the different modules, it's a good system for handling complex information about specimens. And we use Excel to batch upload images and catalog records and to attach those images to the catalog records. So the first step in databasing would be to upload the images to make multimedia records in EMU. So shown on the left is the Excel screenshot of the file that we would use. It contains information such as a brief description of the image, the creator of the image, and we also title the multimedia record. And we use the taxonomy of the specimen to do so. So for this specimen, it would be photo Bryozoa, since it's one of those specimens that has just been identified to the Bryozoa level. Okay, next step is creating the catalog record. So shown here again is the Excel screenshot of the file, and we upload the barcode number and some general information about the specimen, such as the storage medium and storage container. At this point, we also attach the taxonomy record to the catalog record. If the taxonomy record does not yet exist in EMU, we would need to create it before creating the catalog record. So in column C, you can see the taxonomy record IRN, and IRN stands for internal record number. Each record in EMU has its own unique IRN number. So that's how EMU knows which taxonomy record to attach the catalog record to. All right. Okay, so the third step is to attach the multimedia record to the catalog record. So here in column A is the catalog IRN, and in column B is the multimedia record IRN. And now we can see that the multimedia record has been successfully attached to the catalog record because it's now visible in the multimedia tab in the catalog record. Okay, so after we have everything uploaded, we need to enter the verbatim collecting text that's in the label. Volunteers help in transcribing this information. They use the image to do so, which is great since they don't need to have the specimen right in front of them to transcribe it. So they could do this work remotely. Okay, so after the digitizers such as myself, would look at the verbatim collecting text and interpret that information and fill out all the other collection information in the respective fields, such as locality, collectors, collection method, original numbers, etc. And all these fields are standardized. So far, I have seen that locality is the most time-consuming to fill out. So here's the locality. Here's an example of the locality record in EMU. So we would search the database to see if a locality record exists. If it does, then great. If it doesn't, we would need to create one. And so depending on the type of information in the collection label, some localities are easier to create a record for than others. Okay, so the last step would be georeferencing, but we're using quantitative aquatics to do so, as previously mentioned in Nelson Rio's talk. All right, so after we create the EMU record and update it, it's immediately available online. accessible to everyone. So we have links to it in our AMNH Invertebrate Zoology Collections website and the AMNH DigIn website. Oh, this graph looks different now. But okay, so this graph shows the digitized bryozoa records before and after the DigIn. So these records represent at least one bryozoan colony in the specimen jar. Some jars can have multiple colonies. So we had 1,197 bryozoa records before DigIn, so that's the blue. And then due to DigIn, we created 2,404 records. So that's in the green. So in total, we have 3,601 bryozoa records. And so we made a lot of progress, and we have actually completed digitizing the wet bryozoa collection. And this graph just shows my personal contribution to the digitization of these bryozoa records. I created about 50% of them. Okay. So this map shows the localities of our digitized bryozoa collection. So we found out that we had specimens from all over the world in every continent, showing that bryozoans are indeed found worldwide. A lot of our specimens come from the US, but we had a good amount of specimens, about 225 from Antarctica. And those species were endemic to Antarctica, and they were collected from the 1960s to 1990s. So speaking about collection years, this is the graph showing the collection years of our digitized bryozoan collection. So we have a wide range of years. Our oldest specimens come from the 1899 to 1900 expedition to Patagonia by Barnum Brown. We also have a large percentage of specimens from the 1990s, and a large proportion of those came from AMNH's Center for Biodiversity and Conservation. Okay, so in conclusion, digitizing this collection will help to generate a more complete understanding of the world's oceans in the past. It'll help us to understand current distributions, and now this information will be accessible to researchers and the public. And in particular, digitizing this collection is important because these specimens haven't been typically highlighted, so this will give a spotlight to these beautiful and fascinating little creatures. All right, so with that, I would like to acknowledge the NSF DigIn grant for funding this work, the DigIn team, both at AMNH and at the other participating institutions, and the Invertebrate Zoology Department at AMNH for funding my trip here. Thank you. 2 minutes? Okay.
I have a question.
Yeah.
So for existing records, when those materials are discussed, especially if they're sent out on loan, what's your process for updating with the taxonomic records? Do you ask the researchers to make sure using tools in the database?
So I believe what would happen would be we would make those changes in the database. So they would tell us, and then we would update that in our database.
So would you send them the Excel spreadsheet?
I'm not actually sure because I wasn't a part of any loans, but I could ask my collections manager for more information on that. I'm not exactly sure of the process for that. Yeah. Hi.
So I'm sure it differs between specimens, but do you have an idea of how long it takes to capture an image for each one?
Yeah, so it took me about 1 to 3 minutes, depending on the specimen. So as you image more and more, you get faster. But once you kind of get the hang of how to work with the tweezers to get the label, it would be around like 2 minutes. Yeah. Hi. Oh.
Thank you so much, everybody, for your early morning, bright and bushy-tailed attendance. I'm just going to thank again our diamond sponsors, Pitray and Delta Cabinets. We're at the 10 o'clock mark, so we get a half-hour break. We will be back here for more DigIn and ESB awesomeness at 10:30, so feel free to come back and feel free to ask any questions. We're around.